Question 18. An electron collides with a neutral atom and ionizes it. Which of the following describes the particles present after the collision? So there's your atom, there's a nucleus, an electron comes in and it blasts that one off there and a little bit. So, but it also bounces off as well. So it's bouncing off and it's kicking something else out as well. So an electron and an excited atom. Right, okay, this is pretty dangerous. You might want to choose that one. An excited atom is when the nucleus has a higher energy level. It's an excited electron that you end up with, not the atom. So that one's false. An excited atom, no, because it's 2 electrons and a positive ion. Well, there's your 2 electrons. This now has a deficit of electrons, which means that it's going to have more positive charge than negative, so that's true. And 2 electrons and a neutral atom in the ground state. No, because you've got too few electrons there, so that one's false. 2 forces, 6 and 10 newtons acted on point, which of the following could not be the magnitude? Well, let's do the extremes first of all. So if there's the point and we've got 10 newtons that way and 6 newtons that way, then that is equivalent to 16 newtons that way. So that's the biggest value. The smallest value is when you have 10 newtons that way and the 6 newtons is in the opposite direction, exactly opposite, and that would give you 4 newtons. Now by angling your 6 newton at different angles like that, so 10 newtons like that, 6 newtons like that, you can get all the values in between. So you can get everything between 4 and 16. So that one, that one, that one, so you can't get 3. A car wheel nut can be loosened by applying a force of 200 newtons on the end of a bar, which is 0.8 meters. So we're going to need the moment here, aren't we? So the moment is equal to 0.8, the length times by 200, which is equal to 160 newton meters. Okay, right. You're probably going to need that. A car mechanic is capable of applying force of 500 newtons to both ends in opposite directions at the end of a wheel wrench. Well, this is a couple, and the moment of a couple is equal to Fs, where F is the force and S is the distance across, that's Fl. So the moment has to be equal to that, so 160 must equal 500 times by the length there, L, so L is equal to 160 divided by 500. Need to work that out. 160 divided by 500 is that one there, B. A ball bearing of mass 2m is projected vertically upwards with a speed of u. Okay, sort of graph question, you need to do a little diagram. So there you've got u. Right. A ball bearing y, oh that's 2m, of mass m is projected at an angle of 30 degrees with a speed of 2u. At the same time, air resistance is negligible. Work these. Which one of these statements is true? Okay, well, we're going to need to resolve this. So let's work out the vertical and the horizontal components. So let's do that quickly. So the horizontal component is going to be 2u times by the cosine of 30. So that's going to be root 3u meters per second. And this one, that's 60 degrees. So it's going to be 2u times by the cosine of 60, which is just u. So look at that. The 2 vertical velocities are the same, which means that in the vertical direction they're going to do the exact same thing. Right, the horizontal component of y is u. No, it's not. It's root 3u. the maximum height reached by y is half that reached by x. No, if they've both got the same initial velocity, they'll both reach the exact same height, even though their masses are different. X and y reach the ground at the same time. That's true because they'll both go up and down at the same time. It doesn't matter that that one's going along as well. X reaches the ground first. No, they'll both reach at the same time, so it's that one. Oops. The relationship between the distance y travelled by an object falling freely from rest and the time x the object has been falling. Well, we need one of the CVED equations here. So here are your CVED equations. The one that we want is this one. S is equal to ut plus a half a t squared. That's equal to 0 because it says they both start from rest there. Which means that we have x is equal to a half a t, oh sorry, my apologies, y is equal to a half a x squared, so that means that y is proportional to x squared because that's all a constant, because gravity is constant. So y is proportional to x, oh there it is. The car exerts a driving force of 500 newtons when travelling at a constant speed of that. What's the work done in 5 minutes? Well, the work done is equal to the force times by the distance. So that's equal to 500 times by, well, the distance is going to be per hour. So we need to times by 1,000. And then we need to divide that, times that by the time. And the time in hours is going to be 5 divided by 60. So let me just explain what I did there. So the force times by the distance is velocity times by time. So the velocity is 72. I want it in meters, not kilometers, so I times by 1,000. And I've got to be careful, that's in hours, so I need to change that to hours. So 5 minutes divided by 60 turns it into hours. So here goes 500 times by 72 times by 1,000 times by 5 divided by 60 is, press the ENG button, so 3 times 10 to the 6, 3 times 10 to the 6, that is. Question 24. Two masses hang at rest from a spring as shown in the diagram. So at rest means they must be in equilibrium. The string separating the masses is burned through. So there's the string, there's the spring. Which of the following gives the acceleration to the two masses when it breaks? Right, so we can do the 2 kilogram one straight away. It will just fall under gravity, so it's got to have 1g. So it's got to be one of those three. Now let's work out this one now. So the first thing we need to do is to think about what it's like before the string breaks. So before the string breaks, there is a force of mass times gravity on this one, so that's just g, and mass times gravity on this one, so that's 2g, and there is a force of tension up here, tension, and because it's at rest, it's in equilibrium, so the tension going up must equal the two forces that are acting down, so therefore that must equal 3g. Okay, when the string breaks, you've got this situation. You've got 3g going up because the spring is still extended to the same amount it was when this was on, but now you've only got mg acting downwards, and that's m is 1 kilogram, so that's just g acting downwards. So the resultant is going to equal 3g minus g is equal to 2g, and that is equal to the mass times by the acceleration. So if 2g is equal to ma, then a is equal to 2g divided by the mass, and the mass of that block there is just 1. So it's 2g going upwards, so it's that one or that one, so it must be C there. An object falls freely from rest. After falling a distance d, its velocity is v. What's the velocity after it falls a distance of 2d? Well, for this one you're going to need your Suvad equations, so it's that one there, it's the most useful. V squared is equal to u squared plus 2as. It falls from rest, so that's 0. So you've got v squared is equal to 2as, or v is equal to square root of 2a times by the square root of s. So that's a constant, because acceleration due to free fall is a constant. So v is proportional to the square root of the distance. So if we double the distance, we're going to put 2 in there, which means that we're going to get a root 2 there, so it's got to be that one there. An electric motor, input power 100 watts, raises a 10 kilogram mass vertically at a steady speed of 0.5 meters per second. What's the efficiency of the system? So what's the power out is going to equal the force times by the velocity. Well, if we have something raising up at a constant speed, then it's got to be in equilibrium. So we have the weight here, which is mg, and the force pulling it up has got to equal the same as that, so they're in equilibrium. So we have the mass is 10 times by 9.81 times by the velocity is 0.5. So the power out, well, that's about 10 times 10, so that's 100 times by a half is 50. So power out is 50 watts, power in is 100 watts, so that's 50% efficient. So that number divided by that number. So that's question 26. 27. The velocity of a vehicle varies with time as shown by the following graph. Which of these represents the force? So the resultant force is equal to the mass times by the acceleration. The mass of the car is presumably staying constant, so force and acceleration graphs would look identical because they're proportional to one another. So if we can work out what the acceleration is, we can do this. So the acceleration is the gradient of the velocity time graph. So there the gradient is 0, there the gradient is positive, and there the gradient is 0 again. So we have to have a graph that starts at 0, goes up to a positive value, comes back down to 0 again, which is that one there. None of these do that. Which one of the following provides direct experimental evidence that light is a transverse wave rather than a longitudinal? Well, you're looking for polarization. Oh, there it is. That's the only experimental evidence to show that it's a transverse wave. A string passes through a smooth, thin tube, so you might have done this experiment. Masses, and you spin it around. Masses m and m are attached to the ends of the string. The tube is moved so that the mass travels in a horizontal circle, constant radius r, at a constant speed of v. Okay, so the force in this string is the tension is the same here as it is here. So this is an equilibrium here, so the tension is equal to big M times by G, and that's equal to the centripetal force. So there's a force keeping this in circular motion. The only force acting on it is in the horizontal direction is the tension. It's also got its weight acting down, which means you can't get it to go horizontally exactly. You have to have it slightly bow down at a slight angle. But let's ignore that for the moment. So the tension mg is equal to centripetal force. So mg is equal to mv squared over r. So that's using your centripetal circular motion here, mv squared over r. We need to rearrange that to get m, so m is equal to mv squared over gr, which is that one. The maximum velocity and the maximum acceleration. Well, let's look at these two. Maximum velocity and maximum acceleration. So here's simple harmonic motion. Here. So the maximum velocity is omega v max is equal to omega a, because it's when this expression here is equal to 1. So it's when, well, it's Vmax equals omega, oh sorry, V equals omega, right, I'll just start that bit again. 5, 4, 3. Right, so let's just do these two, the maximum velocity and the maximum acceleration. The maximum velocity is given on the formula sheet by that equation there. And omega equals 2 pi f, so 2 pi f times by a. So if the frequency doubles, then Vmax does double. A max is equal to omega squared times by the amplitude, so that's 4 pi squared f squared times by a, so that's going to increase by 4 times, so it's definitely not that one. We've worked out it's that one. The total energy, well, the energy is proportional to the velocity squared, because when it's all kinetic energy, it's a half mv squared, so if that one doubles, then the kinetic energy, so therefore the total energy will go up by 4 times, so it's not that one. The particle oscillates with undamped simple harmonic motion. The acceleration of the particle is always opposite to the direction of velocity. No, it's always opposite to the direction of displacement. Decreases as the potential energy increases. Come back to that one. Is proportional to the frequency. Well, the acceleration maximum is proportional to the frequency squared, so that one's not true either. Is least when the speed is greatest. Well, if we look at our equation for acceleration, it's least when this is 0, and when the displacement is 0, that's when the particle's in the middle and it's got maximum velocity. So when that's 0, that's at maximum. So that one is true. So let's just make sure we can prove this one is wrong. Decreases as the potential energy increases. Right, so the potential energy is increasing at the edges of the displacement. So that's the displacement, that's the potential energy, and you get that graph there, don't you? So it decreases as the potential energy increases. Well, the acceleration will be biggest when the displacement is biggest. So it increases as the potential energy increases. So that one is false. So that's all of those. I hope you learned something from this. If you found it useful, then please tell your friends about it and share it. And thank you for watching, and good luck in your exams.